To solve the system, we're going to just need more elimination stuff. Now remember, if we saw something like y equals or x equals, it'd be easy to use substitution or replacement, but it's not. These are both in standard form. Now it doesn't matter if this one equals 0 either. What we're mainly concerned about with these are the coefficients. And we see right off the bat that the coefficients of x's right here and here are already opposites. We have a -6, and then you could label it, although you wouldn't necessarily need to, you could label the other one as a +6. It's up to you. But the reason why we want to see that is because those coefficients of x are opposites. So that means we can eliminate them. Okay, so to eliminate them, just like we saw last time, elimination can also be shown as addition. So whether you show the addition signs or not is really up to you, but here I've got a -6x plus a 6x, which actually is going to make that a 0 right there. So we've zeroed that out. But then I've got 1y plus another 1y. So how many y's is that? That'd be 2 y's. And then this would equal, you can do a plus 0 or just whatever, it's still going to be 8. And I now have a one variable equation with a y that is a one-step equation to solve. So to solve this, I'm just going to take both sides and divide them by the coefficient of 2. And that's going to give us a phantom 1y, which now equals 8 divided by 2, which is 4. So we know that our answer should be an ordered pair with an x and a y value. We just found the y value to be 4. Now that I have that y value, I can go back to one of the two original equations, and then I can solve for the corresponding x value. So like I've said before, it doesn't matter which one you choose. I tend to just stay with the top one, just so there's some consistency in what we've seen already. So that's -6x plus y. You can show the 1 if you'd like. And that equals 8. And in that equation, we're pretty sure we just found the y value, which is, it should be 4. So I've replaced the y with 4, and now I have an equation to solve for x with. So there's no distribution here. No combining like terms. We go straight to principles of equality. All of my x's are already on the left, so I'll keep them there. So all the numbers should be on the right. -6x is on the correct side, kind of as planned, but the +4 right there is on the wrong side. So it does not have an x. So I'm going to have to subtract 4 from both sides to zero that out. That allows me to drop the -6x's. And 4 minus 4 there would be 0, and that was part of the plan as well. Then we have 8 minus 4, which is 4. Last thing I've got to do, because I've isolated all my x's on the left, so the last thing I'm going to do here is I'm just going to make the coefficient of x a phantom 1 like this, and I'll do that by dividing both sides by the current coefficient of -6. -6 divided by -6 is 1, so it's a phantom 1, and then 4 divided by -6 would give us -2/3. Okay, so that should be our x values for both, right? Because it's the intersection of the two lines. -2/3. That is a fraction. Let's find out if it works though. So I'm going to put these two values into my calculator. I'll start with the top equation. So that's -6 times -2/3, and then plus the y value, which we found was 4. I push enter. Let's see. Yeah, so my calculator gave me the wrong answer, but it's because I typed it in wrong. So the work looks pretty good. Yeah, the first one checks off. It looks like if you were to replace the x with -2/3 and the y with 4, you get a true statement on that first equation. So I'm going to go to the second one. I'm going to try to type it in correct this time. So 6 times -2/3, and then plus the y value, which is 4. And when I push enter, I expect to see 0, and I do. So that one checks off as well, meaning that we have in fact found the solution to the system. The objective, just like we saw last time, is we still are going to be solving systems of equations with elimination. That means, just like we saw in the bell work, although we may have to force coefficients to be opposites, then we add the two equations together to eliminate one of the two variables, usually the one that has opposites, of course. And then we solve that equation for the one variable. Then we take that value, replace it into the other equation to solve for the other variable, and the last thing we should do is check. But we're going to be using a calculator to check. So take 15 seconds, copy this down, then we'll get started. This is the process that we saw last time. So like I was explaining on the bell work, is if you ever have an equation that shows like a y equals or an x equals kind of stuff, then I would not use this strategy. Meaning I would pretty much skip the first step here, because then I can use substitution. Now you don't have to, you can use whichever method you like. In fact, you could use graphing on all these and you could still solve it. But if we need to, we will change the way the equations look. For now, the equations that we deal with should be in standard form. ax plus by equals c. And then the other equation will have the same format, so we need to align the x's, the y's, and especially the equal sign. Because if they are aligned, then we can force the coefficients to be opposites, and that's step 2. We'll multiply the equations by some value in order to make the coefficients opposites. When they are opposites, then when we go to step 3 and actually add the two equations together, just like we saw in the bell work, they will zero out. One of the variables will zero out, and then you will solve for that variable, whatever variable is left over. Once we have that value, then we replace that value into one of the two original equations. We solve that for the final variable, and then we just check the solution, but we're going to be using calculators to check those solutions either way. So this is not a new process as long as you did the work last time and paid attention. If this is new, well, we're still going to go over it, so the lesson from last time you can still understand if you'll pay attention today. So here's our first equation, first system of equations. Now, like we talked about already from last time, is you got to look at these two equations, and the first thing you should do is just see if there's one of the two variables that will maybe be easier to eliminate. Meaning, usually that would mean that one of the two variables has coefficients that are multiples of each other. So I'm talking about the 5 and 10, all right? -4 and -7, I'd have to multiply both equations by something to get these to be opposites, which you can do. But since I see that this 10 is a multiple of 5, I don't care about the signs right now. This means that I can multiply this top equation by 2, and when I multiply the 2 by the 5x's, I will get 10x's. Now that will make the coefficients match. I need them to be opposites, so I'm going to multiply it actually by -2 instead. So what new equation will we have? Well, again, it's distribution, but it's really a principle of equality. Whatever I do to one side, I've done to the other. But I'm going to do it to all the terms. So -2 times 5x's would be -10x's. Then we'd have -2 times -4y's, which would be positive 8y's. And then this would equal -2 times -9, which is positive 18. Now, this equation has the exact same value as this equation because we did the same thing to all the terms. So that's a principle of equality, and we've kept the value of the equation, but we've changed the way it looks. That second equation, we didn't do anything to it, so it's still a 10x minus 7y, and it equals -22. So what was the point of that? The point was to make the coefficients of x's to be opposites of each other. And we only had to do it to one equation. We didn't have to do it to both, although probably today we will. But now that I have x coefficients that are opposites, I can take the two equations and I can add them together. So I'd have -10x's, you could say plus 10x's. That will zero that out, which was part of the plan. Then we have the y's as well. That would be 8y's minus 7y's. That's going to leave me with 1y. That's actually good news. I'll show you why here in a second. But then we've got -18 plus -22, which would be -4. Now this is solved because the coefficient of y is 1, meaning that in our ordered pair solution, we now have a y values. So it's always x and y. We just found the y value is -4. So as part of our solution, we have the -4y value. We are just missing the x value. So since I do want the x value, I go back to the two original equations up here. 5x minus 4y equals -9, or 10x minus 7y equals -22. It doesn't matter which one you choose. You can choose the top one, the bottom one, doesn't matter. I'm going to just stick with what I've been doing for class. I'm going to stick with the top one. So that's 5x minus 4y equals negative 9. Okay, but in this equation, we just found a y value that is negative 4. So I'm going to take that y, and I'm going to replace it with negative 4. Now this becomes an equation for me to solve. So we do have some distribution. That would be negative 4 times negative 4, which is positive 16. So now it's 5x plus 16 equals negative 9. So that's all the distribution. No combining like terms, so we'll go straight into principles of equality. And since all my x's are on the left, I'll keep them there. And then my numbers should be on the right. So the 5x, it's okay, it's on the x side, but the 16 doesn't have an x, so it has to be zeroed out. So minus 16 from both sides. So the 5x will drop, which is part of the plan. 16 minus 16 will zero out, also part of the plan. Negative 9 minus 16, though, we don't really care what that is, but it will help us to solve the problem. So we got 5x equals negative 25. The last thing I need is a coefficient of x. I'm going to show it as a phantom one. So how do I make a phantom one? Just divide it by itself. But if I do it to one side, I've got to do it to the other side, which I've now done. Negative 25 divided by 5 is negative 5. So that came out as a whole value. We didn't see any fractions like we did on the bell work. That's okay. This should work. So I'm going to go up here, and I'm just going to check my answer in both equations to make sure that would be true. So 5 times negative 5 minus 4 times negative 4. You can put this in the calculator. It'd be 25 minus 16, negative 25 plus 16, I guess, which would be negative 9. So the first equation we have checks off as true when you replace the x with negative 5 and the y with negative 4. But I've got to replace the x and the y with those values in the second equation. So that'd be 10 times negative 5, that's negative 50, minus 7 times negative 4, that'd be positive 28. So negative 50 plus 28 would be negative 22. So the second one checks off as well. That one's good. So that means we did find the solution, which is good. That's what we want. Okay, here's our second one. 4x plus 10y equals negative 24. And we also have negative 2x plus y equals negative 24. Guys, try this one out. See if you can do it, and then we'll go over it. So on this one, again, a little bit of analysis, and you can see that making the coefficients to zero out, it really doesn't matter which one you choose. I'd say it's going to be pretty nice for both. Some students like that the coefficient of our y on the second equation is 1, because you can make that easily a negative 10. I would look probably at multiplying by a lesser value, because that means that second equation you're going to have to multiply by negative 10. Which is going to give you fairly large numbers, which you can deal with, and the calculator does all the work. So if you'd like to do that, you can. But for me, what I'm going to do is I'm going to work with the coefficients of x, because I see 4 is a quick multiple of 2. And they're already opposites. The 4 is a positive 4x's, and the 2 is a negative 2x's. So the signs are opposites. I just need the numbers to match. So to do that, I'm going to take that second equation here, and I'm going to simply multiply it by 2. And when I do this, right, because my first coefficient of x here is a positive 4x, but by multiplying that by 2, the new equation will have a coefficient of x that is a negative 4. So again, that's to make the coefficients of x's opposites so that they will zero out. So that came from the 2 times the negative 2x's, but then I'd have 2 times 1y's as well. That'd give me positive 2y's. And then I'd have 2 times negative 24. You can put that in the calculator. It's going to be negative 48. Now that first equation stays the same. It was still 4x plus 10y equals negative 24. And as we had planned, the coefficients of x's are now opposites, so I can eliminate those or zero them out. So 4x minus 4x, that'd be 0 x's, so I've zeroed that out as planned. The next one would be 10y's plus 2y's, so how many y's is that? 12, 12y's. And then negative 24 minus 28 would be negative 72. There we go. Now we're pretty close to having the y value, but the last thing we need to do here is make the coefficient of y a phantom 1. So we'll do that by dividing both sides by the current coefficient of y, which is 12. 12 divided by 12 is 1, that's my phantom 1. And negative 72 divided by 12 would be negative 6. So in my ordered pair, I now have a y value. I'm missing the x value, but I can put my y value in as negative 6. So I'm pretty sure the y value is negative 6. I come back to the beginning, and I look at these two equations. I've got to solve now for the x value. It doesn't matter which one I choose to use, though. Again, just to remain consistent, I'm going to choose the top one. 4x plus 10y equals negative 24. Now, if you chose the bottom one, you should get the same x value, but we'll find that out when we check the answers. So here, we're pretty sure that the y value is negative 6. So we're going to replace that y with negative 6. And we just need to solve this equation for the x value. So 10 distributed to negative 6, that's times 6, would be negative 60. Now we got 4x minus 60 equals negative 24. My next principle of equality should zero out the negative 60 because it's on the wrong side. So I'm going to add 60 to both sides. Okay, so I can drop my 4x. We've zeroed out the negative 60 in orange as planned. And then this would equal negative 24 plus 60, negative 40, 36, 36. And the last thing I got to do here is make my coefficient of x a phantom 1. So I'll do that by dividing both sides by 4. X equals 9, or it should equal 9. So I put that in my ordered pair. But let's just double check. So that'd be 4 times 9 is 36, plus 10 times negative 6, that's negative 60. 36 minus 60 would be negative 24. That's good. And then we got negative 2 times 9, which is negative 18, plus negative 6. Negative 18 minus 6 would be negative 24. Both of these check off when we check them by replacing the x with 9 and the y's with negative 6. So that means we have, in fact, found the solution. Now this one, if you were to analyze this one, you'd probably say maybe you'd get rid of the y's first. Let's say that you're not figuring that out yet. Okay, so here's a good strategy for eliminating, it doesn't matter which variable, but you can eliminate the variables simply by taking one of the coefficients and multiplying it into the other equation, but you got to do it twice. So here's what I mean is for this equation, this system of equations here, I'm going to choose to eliminate the x's. Now, does that mean that it's the most efficient way to do this? No, but I'm not saying it's the least efficient, the least efficient. So here's what I mean by this, what I just said, is I'm going to take this top equation. Since I'm eliminating the x's, I can take the coefficient of x in that second equation, 7, and I can simply multiply it into this equation. Now, if I needed to work with the signs, I would, but they're already opposite signs, and since I'm eliminating the x's, I need these signs to be negative and positive. So I don't need to do anything to the signs. I'm just going to multiply the 7 there by the negative 2x, which should be negative 14x's. Then I've got 7 times 2y's, which would be positive 14y's. And then 7 times 6, which would be positive 42. So that's my new equation from the top. Now, since I already said this, my goal is to eliminate the x's. I'm going to take the first coefficient of x, which was negative 2, and now I'm going to multiply that into this second equation. So I'm going to multiply this by negative 2, hold on. Yeah, I'm not going to multiply it by negative 2. I want that to be a positive 14. If I had multiplied that by negative 2, it would have given me a negative 14. So yeah, it looks like there's still a little bit of analysis going on there. So you have to make sure that the coefficients are opposites when you multiply. So right here, I have 2 times 7x's, which would give me 14x's. Now again, if I had made this to a negative, it would have been negative 14x. We can't have that, and the only reason I can do this is how I do it is just to take off the negative. So now it's a positive 14x. If I were to combine the two equations, that will zero out. That's part of the plan. But I've got to do the rest of this distribution, or principle of equality. 2 times 4y's would be positive 8y's. And then this would equal 2 times 34, which should be positive 68. Okay, so the way I have this set up, my x's now should zero out, or eliminate. So that'd be 14x's plus negative 14x's plus 14x's. Again, that zeroes out as planned. For my y's, I've got 14y's plus 8y's, which should be 22y's. And then this will equal 42 plus a 68, which is going to be, carry the 110. So with this now, I can solve for y by making the coefficient of y a phantom 1. So I take the 22 and divide it by itself. It's just if I do it to one side, I got to do it to the other side. And it appears that the y value is going to be a solid 5. So in my ordered pair, x's and y's, I just found a y value that is 5. What I need now then is the x value. So again, I'm gonna use the original first equation, which was negative 2x plus 2y equals 6. But if you wanted to use that second equation, you could. And right now we're pretty sure the y value is 5. At least it seems like it is. So I need to solve this equation. First up, we got the 2 times 5 distribution. That's going to be positive 10. So negative 2x plus 10 equals 6. Now principles of equality. So I'll put my x's on the left, numbers on the right. And the 10 in green is on the wrong side. So I'm going to have to zero that out. Minus 10 from both sides. So the negative 2x drops. 10 minus 10, that zeroes out as part of the plan. And 6 minus 10 there is going to be negative 4. Last thing I need is a coefficient of y that's a phantom 1. So I'll divide both sides by the coefficient of, I said y, I meant x. And don't make that mistake. That could have turned out pretty bad. But I've got to divide both sides by negative 2 for my x value. Negative 4 divided by negative 2 is positive 2. So my x value should be 2. But let's go back and check. So up here, this would be negative 2 times 2 is negative 4, plus 2 times 5, which is 10. Negative 4 plus 10 is going to be positive 6. So that first equation, it does check off. The second equation, 7 times 2 is 14, plus 5 times 4 is 20. 14 plus 20 is 34. So that checks off as well. And now I know that I have found the solution. All right, so to go back to the beginning, this is new for us, which you could have eliminated the y's, I think, maybe a little faster, just because you could have multiplied this top equation by negative 2. But you can't eliminate the x's this way. So if you're struggling to think, well, what I got to multiply the equations by, you can multiply both equations by something and then get those coefficients to be opposites. All right, so let's go through this one. Again, I'd probably say here maybe the y's would be pretty easy to eliminate. But the x's, actually, maybe the y's will be easier to eliminate. All right. Well, I should have noticed this, but I'm noticing now. This equation on the top is not in the same, it's in the same format, but the y's and the x's are not aligned on this one. So don't make the error of just saying, well, I'm going to multiply this top equation by 2, and then you got 4 y's, because you wouldn't combine those with the negative 4 x's, okay? So here's what I'm going to do. First, before I do any multiplication, I'm going to rewrite. It doesn't matter which equation. I'm going to use the top one. The top equation, I'm going to take it, but I'm going to rewrite it so that the x's and y's are are aligned in columns. Meaning the 2y, I'm going to write it first, and it is positive because of the plus sign. And then the negative 5x I'll write second, but I'm going to show it as minus 5x. Okay, it'll still equal 1. That's okay. Now we've got the other equation, negative y minus 4x's equals 19. And this now should be a little bit more clear that the y's are going to be easier to eliminate. Can you eliminate the x's? Yeah, you'd multiply the top equation by positive 4, maybe, and then the bottom equation by positive 5, something like that. But for me, I'm going to choose to eliminate the y's because my current coefficient of y is a -1. But I can easily make that a -2 simply by taking the full equation and multiplying it by 2. So this will give me a new equation, right? So I've got 2 times -1y's, which is -2y's. I've got 2 times -4, which is -8x's. There's 2 times -4x's. And then I've got 2 times 19, which is equal to +48. So this is my equation. The top equation I don't need to do anything to because the coefficient of y's are now opposites, 2y and -2y. But we also have the -5x, and then this equals 1. So with this now, we should be ready to eliminate the y's because they are opposite coefficients. Yeah, 2y's minus 2y's, that will zero out as planned. Then we've got our x's, -5x's minus 8x's will be -13x's. And this is going to equal, that'd be 1 plus 48, which is 49. Yeah, make sure you're doing the math right here. It's going to jack that up pretty bad. So 2 times 19 is actually 38. That's better, because now when I add those together, I'm going to get 39. All right, it's good to catch that right now, because if I had gotten to the end, I probably would have gotten a really ugly answer, like some kind of nasty fraction or decimal. But I noticed now, so we can continue. I'm going to make the coefficient of x a phantom 1 by dividing both sides by -13. And yeah, this is great because it's going to just give me -3 there. So the x value I have is -3 in my ordered pair. So I take my x, I put in -3. I still need my y value. Doesn't matter which of the two equations you use from the beginning, just one or the other. Like I said, I'm going to try to stay consistent here and use the top one. So I got -5x plus 2y equals 1. And we're pretty sure the x is -3. So when I replace that with -3, I have an equation now to solve for y. So let's do that. So distribution, -5 times -3. I guess I don't need the principles of equality, huh? But -5 times -3 would be +15. Then we got plus 2y equals 1. Now I'll use principles of equality. So on this one, we'll do, put my y's on the left, numbers on the right. Because all my y's are already on the left, I'll subtract 15 from both sides because it's on the wrong side. That'll zero that out. Then I can drop my 2y, which now equals 1 minus 15 is going to give me -14. And then I'll divide both sides by the coefficient of y, which is 2. I get -7. So my y value, my corresponding y value, it should be -7. But let's just check to make sure. So back at the top here, I've got -5 times -3. That'd be 15 plus 2 times -7, which is -14. 15 minus 14 is 1. So that first one checks off. The second equation would be -7. So that'd be 7 minus 4 times -3. It'd be -12. It'd really be, what did I get? 7 plus 12, which is 19. So that one checks off too. Now I'm doing that in my head, or I'm just kind of doing it by the order of operations, but I would recommend that you guys just plug those values into the equations and then see if it's true with a calculator. But it's up to you. So we're good. We found the solution. Since our strategy is elimination, the first part here, where we should have the basic form of the equations, they should be in standard form. AX plus BY equals C. They should be in this format. Now, just like we saw in that last problem, though, sometimes the x's and y's are switched, so you have to be careful with that. Make sure that the x's and y's are aligned in order to solve these with elimination. And then even on these problems, just like we saw with substitution, they should tell us what the variables should be, like maybe a or y or x, doesn't matter. And then at the end, we'll make sure that we label our answers because these are word problems. So here we go. We got a school needs to buy new notebook and desktop computers for its computer lab. The notebook computers cost $250 each, and desktop computers are $175 each. How much would it cost if someone were to buy 14 notebooks and 16 desktop computers How much would it cost if they got N notebooks? Oh, okay. This one, I guess we don't even need elimination on this one. This goes back to, geez, I think Unit 1. It may have been Unit 2. Whatever. So here's what we got. We know that the cost of a notebook computer, I guess, $250. Okay, so $250 is for my notebook computer. Now, in this part of the problem, it says you're going to purchase 14 of those notebooks. So that's 250. 250 is for one. You could add 250 to itself 14 times, but I'm going to take a shortcut and use multiplication. So if I take the 250 and multiply it by 14, that will give me the cost of just the notebooks from this part of the problem. After the notebooks, then it says you're also going to purchase some desktops. Okay, well, desktops, it says that they're going to be $175 each. Now, that's one computer right there. But then it says over here, you're going to purchase 16 of those desktops. So, again, you can take 175 and add it to itself 16 times. I'm just going to multiply it by 16, though. And this part of the expression tells me how much just the desktops, 16 desktops, will cost. But it says, how much will it all cost? So, for that, I'm going to add them together, which I will need a calculator to do. And this will tell me how much it will cost. Since I'm looking for a cost, right now, before I do any other work, which I'm going to do in the calculator, I'm going to label my answer with a dollar sign because that will tell me cost. So, in the calculator, I've got 250 times 14 plus 175 times 16. I push enter, and my calculator says that cost would be $6,300. Okay, so that's the first part. How much would 14 notebooks, 16 desktop computers cost? $6,300. The second part, how much would it cost if they got N notebooks and D desktop computers? So this one, we're just writing the expression. So we still have the same two types of computers. First, notebooks. And then second, desktops. This one we will not be able to solve like the last problem because we don't have any specific values, but notebooks we know are going to be $250 each. We just don't know how many they're going to purchase, so they said to use N. So N for notebooks, I take 250 times N. That will tell me how much this number of notebooks cost, even though we don't know the amount, but it allows me to have a formula for it. Desktops, though, are $175 each. So that would be for one of those desktops. We just don't know how many we're going to purchase. They said to use D for desktop computers. So again, 175 times D, number of desktops, becomes a formula for us to use for any number of desktops. The previous part of the problem said to use 16, so we replaced the D with 16. Well, if you were to add these together, then you would have a total cost for this number of notebooks and some other unknown number of desktops. So this is good right here. The first box, you'd have this value, and then the second one, you'd put this stuff in. So on this one, you were working 2 summer jobs, making $10 per hour washing cars and $12 per hour landscaping. Last week, you worked a total of 14 hours and earned a total of $152. Determine the number of hours you worked washing cars last week and the number of hours you worked landscaping last week. All right, so we're expecting 2 equations. How do we know we're expecting 2 equations? Because we're in the systems unit, so expected, okay? Now, what type of equations are we going to be writing? Well, they're kind of like the last problem. And the first part here, you got 2 jobs. First off, you're going to be washing cars, and then second off, we'll say you're doing landscaping. Then that gives us 2 total values. You got hours, 14 hours, and then you got a certain number of dollars that you gained as well. So this tells me that I need 2 equations, one based on the hours, and then the second one based off of how much you earned. So to start out, I'm going to start with just the hours worked equation. Okay, so how many hours did you work? Well, that's what we're actually trying to find out. How many hours you worked washing cars last week and how many hours you worked landscaping. So here's what I'm going to do. I'm going to take washing cars last week, the number of hours washing cars, And I'm going to say that's my W variable. Now, you could use X and Y if you wanted to. It doesn't really matter. But for me, W is going to represent number of hours washing cars. Okay, so this right here is just washing cars. Then, in addition to that, you also have some number of hours that you're going to be landscaping. So, landscaping, I'm not going to use L just because it kind of looks like a 1. In fact, for this one, I'll say that's my X. So, for landscaping, I have X, which is number of hours that you spent landscaping. So, separately, this is how many hours you worked separately. But I know that if I were to add these two values together, I would get some total number of hours that you worked, which it says up there was 14 hours. So this is my first equation. And this may take some time to really understand how to write these equations because a lot of students do struggle with this at first. But my second equation is going to be based off of how much money that you earned. Okay, but I'm going to keep these here. I got the number of the amount of money that you'll make washing cars and landscaping as well. Two separate jobs. Okay, so how much money will you make washing cars? Well, it says up here that you're going to make $10 per hour washing cars. So, if you put a 10 right there for washing cars, that's just how much you would get for 1 hour. But we don't know how many hours you work, which is why we're using W. So I'd have to multiply the 10 by W, the number of hours you spent washing cars, in order to figure out how much you earned washing cars. And 10 times W then is that expression. Now landscaping though, up here at the top it says that landscaping you're going to make $12 per hour. So if you're just landscaping, you'd make $12. That's for 1 hour. We don't know how many hours you're going to work, so we're going to use X right there. Now if I add these together, I should get the total amount that was earned, which it says up at the top there, $152. All right, well, that's pretty good. This is the two equations that are going to help me to solve for the number of hours I worked washing cars and then also how many hours I worked landscaping. But it's a system of equations. So now that I have these two, I'm going to go in and I'm going to use this equation at the top to eliminate, I'll eliminate the W's just because they're smaller. And multiplying by 10 is easier as well. So here's what I'm going to do. I'm going to rewrite the two equations. I got W plus X equals 14. Then I've got 10W plus 12X equals 152. So the top equation, I would like the coefficient of W to be a negative 10W. So that it is an opposite with this 10W here. So I'm going to have to multiply that top equation by negative 10. So negative 10 times W, that is the negative 10W. Negative 10 times the 1x would be negative 10x's. And then negative 10 times 14 would be negative 140. Fairly easy multiplication, but you can use a calculator for it if you need to. The second equation we're not going to do anything with because I've got my W coefficients as opposites. So that's 10W plus 12X equals 152. And with this, I'm now ready to eliminate the W's. So I'm going to add the two equations together. Negative 10W's plus 10W's there to be zeroed out as planned. Negative 10X's plus 12X's would be 2X's. And then this is going to equal negative 140 plus 152, which appears to be 12. Now, this means that if you double the number of hours you work, then you'd get $12. Because we can interpret these as we go, because it's a word problem. Last thing I need, though, is a phantom 1 coefficient of x. So I'll do that by dividing both sides by 2, and I get 6. Now, it's not an ordered pair. I'm not solving for an ordered pair. What I just found there was x. X is landscaping hours worked. So this would be 6 hours worked landscaping. 6 landscaping hours. So there's one of the solutions. So if you work 6 hours landscaping, how many hours did you spend washing cars? This equation is going to be a lot easier to use, so I'm kind of glad that it's the top one. But it was W plus X equals 14. And right there, we just found the X value is 6 hours landscaping. So quick, easy equation to solve. We'll just subtract 6 from both sides. So that zeroes that out. I got my number of hours washing cars. Appears to be 8. So again, it's as a word problem. This is 8 hours washing cars. Okay. That's it. That's all we got to do on this. Now, the last thing we should do, though, is just kind of check at the end. So I'm saying, will the number of hours washing cars and landscaping be 14? Yeah, 8 plus 16 is 14. That's the easy one. Okay, well, what about $10 per hour washing cars, $12 per hour landscaping? So 10 times 8 is 80, 12 times 6 is 72, 80 plus 72 is 152. So both of these check off when we plug X in as 6 and 8 as W. So it means we have found the solution there. So yeah, there is a mastery quiz next time, but now that we've gone through this, we should be able to solve systems of equations with elimination, even if we have to do it with word problems. And, those were the most fun, so we love it.